Can stress corrosion cracking break critical infrastructure? Imagine a bridge or a pipeline suddenly failing without any obvious signs of damage. That's often how stress corrosion cracking, or SCC, can cause unexpected problems in vital structures. Stress corrosion cracking happens when a metal that is prone to it is exposed to a corrosive environment while under tension. This tension can come from the way the metal was made or from the stresses it experiences during use. Over time, tiny cracks form inside the metal, often invisible to the naked. These cracks grow slowly but can suddenly cause a part to break. Unlike uniform corrosion, which wears away the surface evenly, stress corrosion cracking creates microscopic fissures that weaken the inside of the material. As these cracks grow, they can reach a size where the structure can no longer hold. Elevated temperatures make this process worse because heat speeds up the chemical reactions between the metal and the environment. Critical infrastructure like pipelines, bridges, pressure vessels, and offshore platforms are especially at risk. These structures often operate under constant tensile stress and are exposed to chemicals like chlorides or caustic solutions. For example, stainless steel parts in marine environments or carbon steel components in alkaline solutions are vulnerable to SCC within temperature ranges of 50 to 150 degrees Celsius. Manufacturing processes such as welding, machining, or heat treatment can leave residual stresses inside the metal. These internal stresses can act as starting points for cracks, even if the structure is not under high operational stress. That means a seemingly stable component might still develop SCC because of these hidden stresses. Detecting stress corrosion cracking is tricky because the cracks start very small and are often hidden inside the material. Techniques like ultrasonic testing, acoustic emission monitoring, and slow strain rate testing help find early signs of SCC before it causes failure. Regular inspections are essential, especially in environments known to promote SCC. Preventing SCC involves choosing materials that are less susceptible, controlling environmental factors by reducing exposure to harmful chemicals, and applying protective coatings. Managing residual stresses through proper heat treatment and conducting routine inspections also play a big role. In the end, stress corrosion cracking can indeed threaten critical infrastructure by creating hidden cracks that grow silently until failure. This failure mode is dangerous because it can cause sudden breakdowns without warning. Knowing how SCC works, what environmental factors influence it, and how to detect it early are key steps in keeping our essential systems safe and reliable.